Happy Tuesday! It's so good to see you. Excited about the week ahead. I am going to be out for the majority of this week, but we have a lot of fun ways to learn the content. So, you've probably found me if you are hearing this video here in Nearpod. It's going to be a way that I can bring you lessons. We can also integrate some fun learning games and other elements such as like field trips. So it's going to be a super exciting way to learn. So today we're going to look at structure and function and how those two things tie together directly. And we're going to look again at the characteristics of life. Tomorrow then, on Wednesday, we're going to do a review of all of Unit 1. It's going to be fun. It's going to be a game. I want to see if you're ready to take that unit test. And then as of Thursday and Friday, that's going to open up and you can take your Unit 1 test and totally rock it. I'm excited. All right, so let's jump right into structure and function. All right, I want you to look first at this first tool here on the left. What is this tool? All right. Some of you may have said a shovel, and you are right, okay? Now, I have learned into my adulthood that there are multiple types of shovels, okay? We had a shovel at my house that has a very flat end, and then we have a shovel that looks similar to the one on your screen where you're seeing with the point. All right, if you are trying to dig a hole, which shovel do you think you're going to want to dig holes? That flat-ended shovel or the one with the point? If you said the one with your point, I think you are right on the money. You see, the shape of that shovel is an indicator of what it is used best for. Now, I could use that flat shovel all day long, which I have tried, embarrassingly enough, and it didn't work out as well. All right, but the structure and the function of that shovel end are related. So let's look at this next tool. Anybody familiar with what that is? Right? It's a dustpan. It's a dustpan, and we can make that assumption based on what we know, but we look at how flat it is on the bottom, right? That flat bottom and that gentle slope in shows us that we can use that for getting things into it without a lot of effort, right? Lastly, somebody has to know what this is. What does this look like? Even if you don't know the name of it, what does it look like it's used for? If you said flying, you are correct. And I'm not quite sure what type of a glider it is, but we can look at it based on what we know about its shape, right? It has a very aerodynamic shape. It looks like it's made out of a lightweight material. So because of those things, because of its structure, we can see what it might be used for. It is directly related to its function. That's what I love about science, is if you spend very much time using what you know, all right, and what you see, you can draw some conclusions because there is order to science. And I don't know about you, I'm a person of order. Even if you walk in my bedroom and it doesn't look super tidy, there is a day of the week that I use to make sure that everything is in its spot. There are spots and things for everything. And that's what I love about science. There is an order, there is a process when it comes to all living things. So let's take what we did on the last slide and put it into our science, all right? So right here on the left, you're going to see a snout, all right? You're also going to see some teeth in there. What inferences can you make about those teeth? What can you, conclusions can you draw? What would you need that kind of tooth for? I mean, that's a sharp sucker right there. All right. Even if we didn't know it was an alligator and it was a carnivore, if we see a sharp piercing tooth, just like that shovel that also had a similar shape, we know that it's going to bite down into something, and it's probably going to be something that requires some force. So it's not going to be maybe like an herbivore. It's not going to be biting a leaf, right? So by looking at the shape of that tooth, we can make the conclusion that this could possibly be a carnivore because that looks like a sharp, piercing type of tooth. All right. Another thing we can look at is the nose. All right. This is a human nose on there. But our nose is actually designed for its function, right? What do we do with our noses? We breathe with our noses, right? We breathe in. We breathe out. I guess I breathed out with my mouth. Breathe in and out with your nose real quick. All right, now, beside just feeling like we would look really odd without this septum right here on our nose, it would still allow air in and out, wouldn't it? It would. But it would also allow a lot more things to access our nasal cavity, right? I mean, I'm not going to talk about it if my daughter is in earshot, okay? But my 2-year-old this past spring stuck a piece of foam up her nose. Do you know anything about that? That was not a pleasant process. We had to go to the pediatrician and then the EMT. Long story short, we had to get that out of her nose because it was not a good situation. But if that nasal cavity was larger, things would get stuck in there more often. So by science, by adaptation, our structure of our nose is perfect for getting the amount of air we need in, but yet requiring protection from other things getting in and out. It's a function of breathing. All right, and lastly, I can't wait to talk about this into our next unit, but what these are these are proteins, okay? You might start thinking about steaks, all right? That sounds like a good type of protein for me, and you would be right in thinking that because these proteins are derived from those meats. And in our bodies, we need proteins, and we can actually identify proteins by their shape. All right, so it would be like being able to look at like a tic-tac-toe board and looking at an X and an O, and we'd be able to identify the name of that protein by their shape. All right, and because of their shape, we know the function of those proteins. We'll get into that later, but I really just want you to start thinking that the shape of things, what it looks like, its structure, is a big indication of its function and what it's used for in biology. These are some other examples. We're going to get to these when we dive deeper into the content, but you'll see these in our red blood cells. You'll see this in our fat cells, in our neurons, all kinds of things. We talked about our teeth. And here's one last example I want to show you. I think it's so good, are our eyes, okay? Most animals have eyes or some type of input for sensory, and they're different, all right, based on where they live and the adaptations they have. Their eyes can be closer together, they can be far apart, all right? Some animals are flat and they have two eyes side by side. It's super cool. My daughter Milo was talking about owls today and their ability of rotating their heads much further than we can, right? So our structures have certain functions, and those two things are tied hand in hand. All right, we're going to continue on with some fun activities. We're going to challenge you here on your knowledge of structure and function. So click the right arrow to finish up this Nearpod.